I'd say it's like coffee.
Yeah, definitely getting everything right. 6%
I didn't get everything. I got everything right as well.
What did you get? Well, then what was it? You know, I didn't get everything.
No, I just didn't choose it.
Yep. Okay, we want, where is it? pH, POH, page 4.2D. This is on page 86. Okay, so you need to know that a solution is neutral. A solution is neutral when hydrogen and hydroxide are equal. A solution is acidic when you have a higher concentration of hydrogen, and a solution is basic when you have a higher concentration of hydroxide. Does that seem clear enough? Pretty straightforward. Okay. Why does water have a pH of 7? I think you guys are familiar with it at this point. It only has a pH of 7 only at 25 degrees Celsius. Okay, and that's because, of course, your Kw value is equal to 1 times 10 to the negative 14. And if we were to draw the, what do we call this equation here? What is this equation called? Autoionization of water. So if you write that out, you can write a K for that. Okay, so you can say, okay, we have Kw. Kw is equal to concentration of hydrogen times concentration of hydroxide. And you know that these are 1-to-1, yes? So you know that you could take hydrogen and replace it for hydroxide and it would end up being the same, yes? So we have hydrogen squared is equal to 1 times 10 to the negative 14. So of course, we can then take the square root of both sides. And we get hydrogen is 10 to the negative 7. And because hydrogen is equal to hydroxide, we get hydroxide is also equal to 10 to the negative 7. Is good? Okay. And then if you convert them into pH and POH, you get 7 and 7 respectively. That's where that 7 comes from. Okay. Kw and temperature. Now, first thing, there is a mistake in here. Oh, yeah, there's a mistake in here. At 25 degrees Celsius, the concentration of hydronium should not be 7 times 10 to the negative 7. It should be 1 times 10 to the negative 7. Okay? Do you think that you could calculate all of these values? I don't hear a yes, I don't hear a no. For those of you who were not here yesterday, do you think you could calculate those values thumbs up, thumbs down, or I don't know yet? Yeah, because Kw, of course, is equal to hydrogen times hydroxide, right? And hydrogen is equal to hydroxide. So we're going to substitute in another hydrogen. So Kw is equal to H plus squared. So if you want to calculate hydrogen, what will you do to Kw? Take the square root of Kw. That only works if you're working with water. Yes, if you've got any sort of other solution, acidic or basic, that won't work. But this is pure water. So go ahead, do those calculations. Okay, so if you've got those, the concentration of hydrogen and the pH, what is the concentration of hydroxide, relatively speaking? They are equal because this is pure water. So you can just go through and copy all of those down. Now, what are all of those POHs going to be? Will they be the same? Mm-hmm. Yes. Oh, did I do it wrong? Oh my gosh, what did I do? Oh yeah, that should be 7.08. 7.084. Wow, I don't know what happened there. Yep. 7.084. Thank you. Now, what does that tell you about pKw at all of these temperatures? Is pKw equal to 14? No. So if we have 7.471, we would have 14.942. 14.534. 14.168. 14.000. So taking a look then at all your KWs and your hydrogen ion concentrations, et cetera, if you look at that data, you should be able to tell me and tell your partner if the autoionization of water is endothermic or exothermic. Think that one through. How many people who were away yesterday think they know the answer to this? 1, 2, 3, 4. How many people are kind of like, I don't know yet? Okay, what you want to do is you want to say, what is happening to KW as temperature increases? As temperature increases, KW increases. Okay, so we can say as temperature increases, KW increases. Therefore, at a higher temperature, the equilibrium is, what has happened to the equilibrium at a higher temperature if KW is larger? It is shifted right. Okay, if KW is larger, that means we have shifted right. An increase in temperature favors, does it favor the endothermic reaction or the exothermic reaction? Endothermic, because you've increased the amount of heat, so the system wants to shift to absorb the extra heat. So an increase in temperature favors the endothermic direction. And since it shifted right, therefore the forward reaction is endothermic. Could you write a formula for how to calculate the concentration of H3O plus in pure water? If you were away last day, you're going to put your thumbs up, thumbs down, thumbs in the middle for yes, I can write a formula for how to calculate H3O plus in pure water. No, I can't. I'm sort of got some kind of idea, but I don't know yet. Yes.
This formula is AW.
Yep.
Okay.
Then yes. Cool. Yes? Yes? Okay. So H3O plus equals what? Square root of KW. Excellent. What is true about hydronium and hydroxide in pure water? They equal H3O plus time is equal to OH minus. Now, what I would like you to do is I would like you to decide, is pure water acidic, basic, or neutral at 50 degrees Celsius, and how do you know? Tell your neighbor. Yes. You think neutral. How many people agree with Rigel? Neutral. One person. That's awesome. 2 people, 3 people, 4 people. Anyone disagree with Rigel? Anyone think it's acidic or basic? Why is it neutral? It is neutral. Why is it neutral? Yep. Because the pH and the pOH are equal, the hydrogen and the hydroxide concentrations are equal. Okay, is good. And I think that's it for that. So we are going to go back to somewhere near page 50. Let's see where that is. Somewhere near page 50. La la la, la la la. Page 40. Page 46. So this is a substantial chunk of what Monday's quiz is going to be on, is this kind of thing. And last day, you were looking at what happened if we put an acid with a base, right? We predicted the products. We said which side is favored, yes? Today, we're going to add a little spin onto that. And the spin we're adding onto it, what do you notice about the 2 reactants here? They are both amphiprotic. So how are we going to decide who is going to act as the acid and who is going to act as the base? It was pretty obvious before. The acid had an H and the base did not. But who's going to give the proton and who's going to receive here? Yeah, whichever acid is stronger. And how do you find that out? You look at the Ka value. And if we're really lucky, I probably have them here. Oh, look, I do. Yay. Okay. So we have the Ka. The Ka of the big long one, H2C6H5O7, is 10 to the negative 5. And the Ka of HSO3 minus is 10 to the negative 7. Which one is larger? The H2C blah, 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 the big long one. So the H2C6H5O7 minus is the stronger acid, so it will act as the proton donor. I would like you to write the products then of that reaction. What did I just do? Is good? Okay. I'm going to rewrite it down here. I'm not quite sure why I'm doing this, but that's okay. C6H5O72 minus, and we have H2SO3. Who is the acid in the forward direction? H2 blah blah blah. Its conjugate base is the CHC6H5O72 minus. Yes, that's the conjugate base. That is a conjugate acid-base pair. HSO3 is acting as the base in the forward direction, which means its conjugate acid is acting as the acid in the reverse direction. And there we have a conjugate acid-base pair. How do we know if the products or the reactants are favored? We know that the products or reactants are favored because we need to look at who is the weaker acid and who is the stronger acid. So we're no longer looking at this thing as an acid because we know it's acting as a base. Now we have to look at the two acids in the equation. So we're looking at this one and saying which one is stronger. Well, H2SO3 has 10 to the negative 2. H2 blah 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 is 10 to the negative 5. So H2SO3 is the stronger acid. H2SO3 is the stronger. Could you write which base is stronger? The one on the right, because the two stronger things are always on the same side. They have to be. There's no other way around it, okay? And the other two are weaker. If that's the case, then which side of this reaction is favored? The left side. So the forward reaction is favored. That means that the reactants are favored. So if you think of the two acids as pushing against one another, the acids on the products are pushing away towards the reactants. So you end up with more of the weaker stuff. Yeah? So is KEQ going to be large or small? KEQ will be? Is KEQ going to be greater than 1 or less than 1? Less than 1, because we've got a large amount of reactants and a smaller amount of product. Yes.
Yes, could I ask a question?
Yes.
Since H2SO2 is the stronger acid, that means that the forward reaction is big, right?
Ah, that would be the reverse. Thank you. Not the forward. Thank you. I have problem with all dichotomies. So left and right, those get mixed up. East and west, those get mixed up. Somehow north and south are okay because like they're not like this way. Forward, reverse, like it's just all in my brain. I don't know. My brain doesn't brain that very well. All right. Would you guys like to try this one here? It's a similar problem. Give it a go on your own. Predict the products and decide if KEQ is large or small. If it's large, it's going to be greater than 1. If it's small, it's going to be less than 1.
Yeah.
What? Hopefully you guys are doing a better job than I am. I'm getting everything backwards again. What? What? What is wrong with me? Oh my God. Oh my God. Don't look at anything I'm writing. There we go. Okay. Is good? Now that I've fixed it 7 times, we're doing it wrong 7 times. Now, do you guys want your test on Wednesday or Thursday of next week? What? What? Oh, hang on. Thursday's long block, so it'd have to be Wednesday or Friday.
Wait, why is Thursday a long block?
We've already talked about this, so we're not going to talk about it again.
Yeah.
We talked about it yesterday, I think, which fortunately didn't get recorded, so that worked out well. Wednesday or Friday? Friday, you'll still only get half the block. Okay, so the first half will be learning something. The second half, you'll be writing your test. Yes.
We are not there on Friday.
Why would you not be there on Friday? But it's block 4, not block 2. Oh, we are block 2. No, it's got to be Wednesday. Sorry, too many people missing. It's got to be Wednesday. So your test is next Wednesday.
Do you have a quiz on Monday?
Yes, you do. That gives me Tuesday to give it back to you, and then your test is on Wednesday. And then there's stupid long block things. And yeah, so we have a test next Wednesday on acid base 1. You shouldn't want to put it off anyway, right? Like, I mean, at this point, you should know mostly everything. Lots of you did very, very, very well on the calculation part. So it's just a matter of studying the non-calculation part over the weekend and being okay with that. Rigel?
Shouldn't the ACO be like a K,
Which one? HCO3? Oh, did I use the wrong one? Oh yeah, 5. Oh, it's okay. So I've probably done something wrong here. Just go look at the answer key. The answer key will be correct. Here, let's see what I did yesterday because I did it better yesterday. Where is it? There we go. Look at that.
Yeah.
That's how it should be. That's how it should be. That's what I did yesterday when my brain was working maybe a little bit better than it is today. Okay? Yes. I'm going to just leave it there. So you have a quiz Monday on all things Bronsted-Lowry, so section 4.1. And you have (4.2D). And guess what else is in acids and bases? Like 4.1. That would be properties of acids and bases. And if you would like to remember those properties of acids and bases, on page 53, page 53. There is a way of remembering them, and that is 4.1G. Look at this. Page 53. Control R, Control F. Properties of acids, Control R. C, T, R, L, R. C, conducts electricity. T, taste.
Sour.
R, reacts. L, litmus. And then that's your control. And so that's going to be the same for both the acids and the bases. So they both conduct electricity. Acids taste sour, bases taste bitter. That's CT. And then we have R reacts with, acids react with bases, bases react with acids. L, litmus, acid turns litmus. Red, bases turn litmus. Blue. And then finally R, that's the one that they don't have in common. Acids react with some metals to produce H2 gas, and bases feel slippery. Okay? Is good? I am going to give you your Unit 3 book now, because we might as well distribute it today.
Stay on God, bro. I'm down, bro. Stay on God, bro.
You're dead. Now,
And answer E. Let's not worry about that. Yeah, I'll get rid of that.
Miss Spence? Just to
Hi.
clarify, I'm taking 2 quizzes on Monday. But like, what was the quiz we took on Tuesday about?
KA and PH, so sections 4.2, 4.3.
Okay.
Yeah, so it's
everything-
just all the math.
Okay. Okay, so like basically I just studied the whole unit. Okay.
Yeah. Hi.
See my quiz.
Pardon me?
See my quiz.
Your quiz. Where did I have it? It must be here. From Aaron. There you go.